This is Physics 2211, Lab 1. So the purpose of this lab is to observe electromagnetic interactions between and determine the amount of excess charge on two charged pieces of tape. So the way we're going to do this experiment is firstly, we're going to set up two pieces of charged tape. Then we're going to find interactions between the tapes and the tape in the surroundings. Then we're going to find excess charge on one of the tapes and predict the amount of electrons lost. And finally, we're going to model this experiment in GlowScript and compare. So our initial findings, or I guess a preview, is the charged tape has a net positive charge, which means there's repulsion between tapes, and we found the charge on a single tape to be this and the excess electrons to be this. So the principles used, I guess firstly and most importantly, we're going to be using Newton's second law, which is F net equals ma. And secondly, we're going to be using Coulomb's law, which lets us calculate the force due to an electric charge, which is this equation. And note that K here is 9 times 10 to the 9. So our initial conditions is our length will be 0.2, our mass will be 2e to the minus 4, distance, width, and in this modeling, we're going to say that the system is the top tape and the surroundings is everything else. And please note, importantly, this includes the bottom tape. And we're going to mainly have two assumptions. One, the tape acts like a point charge or a line of charge. We're going to switch between the two. And two, there's no air resistance. So here are our calculations for the experiment. First of all, we can quite easily, because we had that initial mass that we measured, we can quite easily find the force due to gravity. That's because the tape is balanced. There's F net is going to be 0, meaning that the electric force is equal to gravitational force, same number right here. Using that, we can then use the equation Coulomb's law that I showed in the previous slide to find out where Q is. Note that Q is here, Q squared, because they have the same charge. And from that, we can find the number of electrons lost, which is the tape charge over the charge of a single electron, which is 1.6 e to the minus 19. And we get this amount approximately. So here's our computational model, and here's the outcome of it. My arrows were a little big, but that's okay. So note the calculations for the GlowScript code. This is what I got for electric force, what I got from gravitational force, like you saw in the screenshot before. Of course, there's a discrepancy, there shouldn't, but anyway, here is from part 1 of the lab. This is the charge if it's modeled as a point charge. Here is if it's modeled as a line of charges. Notice that they're different. We're going to talk about that later. And the number of electrons lost is this amount. So pretty similar to my experiment. So let's talk about some errors. Well, first of all, it's not the tape isn't a point charge, it is actually a line charge. And some other sources of errors we can get, and well, I mean, first of all, this is just wrong for our assumption, right? But other sources of errors is one, the tape can touch surroundings, meaning charge can be transferred between the tape and the surroundings. Either way, you can lose or gain some, which obviously strongly invalidates the experiment. And second of all, there can just be human error when measuring anything. I mean, length, mass, width, or simply when doing calculations. I've tried my hardest to not have that, but that might be the case. And three, air humidity, because some charge can travel through air if it's thick enough due to humidity. So for our what if, first of all, what if electrons were negatively charged and protons are positively charged? What if the signs of their charges are reversed, meaning if electrons were positive and protons were negative? What would change about the observations you made of your tapes and other charged objects? Well, I think first of all, it's important to note the magnitude of forces does not change or will not change because both pieces of tape would just be negatively charged and they would still repel because like charges repel. So whether they're both positively or both negatively charged, they'll repel either way. So now for our y, this is basically comparing the estimated value of the charge with our experimental data to the value we got from the line charge model. So this is between the point charge and the line charge model, basically part 1 of the GlowScript code, part 2 of the GlowScript code. And so mainly the differences were due to the fact that in part 1, the charge of the tape was calculated, or rather I should say modeled as a point charge, while in part 2 it was calculated as a line of charges. And the latter is much more accurate since it takes into account the length of the tape, while in part 1 we just modeled it as a point with no tape, which is clearly not true because, well, it has a length.